Right, so scientific measurements. So in here, when you're talking about scientific measurements, we are basically trying to talk about how we are going to how do you get to measure things, okay, as a science student, in other words. So there are some basic instruments that we get to use in a lab to get to measure some kind of different quantities. All right, so and those quantities we need to know them also. So before that, you need to know, as we get to talk about this, we have got different types of units, and actually these they do come in the exam. So we have got first what we call a physical quantity. So we have got a physical quantity and also uh, a derived quantity. Okay, now first starting with a physical quantity. When you hear of a physical quantity, it is simply a quantity that consists of a numerical magnitude and a unit. Okay, a quantity that my body is doing some other thing. It seems. Okay, a quantity that consists of a numerical magnitude and unity. So that is what we call as a physical quantity. Just a quantity that is going to have a numerical. Now, if you hear the word numerical, this word I've written here, it's numerical, numerical, magnitude. A numerical is simply meaning number, okay? And then a unit. For example, I'm going to write 20. This is a numerical magnitude. Magnitude is just how big something is. And then I can put a unit, for example, grams. I'm saying 20 grams. Okay, so this is a physical quantity. Okay, meaning that this thing called gram is a physical quantity. But what physical quantity? That is now what we need to know. Because this, we are able to see here, it is just a number which is magnitude and what, and also a unit. Okay, so now when you're talking about these quantities, all physical quantities can be grouped under base quantities and derived quantities. So physical quantities, there are two. So we can have either basic or base quantities, and you need to know because they might ask you, and also derived quantities. Now, when you're talking about base quantities, these are the very basic, like the smallest. Let me say, you cannot, for you to get them, there is no multiplication that you have to do. Like, that's how they are. Okay? That's how they are. For example, here the base quantities, you need to know them. You need to know these. There are seven. Okay? The first one is length. This is a base quantity. The next one, okay, the next one is time. The next one is mass. Okay, apart from mass, you also have temperature. So apart from temperature, you also have electric current. You also have what is called luminous intensity. And then you have amount of substance. Okay, amount of substance. So these are the base quantities which you have to know. Now you need to know the base quantity. You also need to know its unit. So the unit for length, what do you think? If you are talking of length, what can be the unit? Mark, do you know any unit for length?
Unit,
Can you tell me any one unit for length?
um, what about pharmacy?
Okay, do you know length?
Any needs?
Do you know length?
Yes, yes, I do.
What's length?
That means it gives you to for it to the building to for it to like it's any type.
Okay, so length is just a distance. Distance, if you're talking about this is point A, point B. Length is just a distance between these 2 points, okay?
Okay.
So the SI unit or the unit that we get to use to measure length is meter. That is the SI unit. So we use M. And then the SI unit for time. Time can be measured in hours, in minutes, in days, in years. But the SI unit for time is second. The SI unit for mass is kg. The SI unit for temperature is amps. Okay, it's amps. Let me write at the end. This is meter. This is second. This one is kg, kilogram. This one is ampere or amps. And then you have got electric current. Actually, I thought that is current. No, the amps is for current. So I'd put it on a wrong thing there. Okay, so temperature, the SI unit is Kelvin. Temperature can also be measured in degrees Celsius, but the SI unit is a Kelvin. If they brought in the exam, the SI unit for electric current is amps, okay, and ampere. The SI unit for luminous intensity is a candela. So you use C and small d. Okay, that is candela. The SI unit for amount of substance is a mole. So the symbol is just MOL. Are you able to see the board?
Yes.
Okay, so these are the units. Please, you need to know these. You need to know these. So these are what we call base quantities. Now the derived quantities, when you get to mix a base quantity, that is going to give you a derived quantity. For example, pressure. Pressure is a derived quantity. And how do we find pressure? Pressure is given by force over area. You can talk also of velocity. Okay? Velocity is also a derived quantity. Why is it a derived quantity? It is given by distance over time. Okay, there are a lot of things. Acceleration is also a derived quantity. Force is also a derived quantity. So there are many quantities. As long as you are getting more than, if you just get any one of these units, you either multiply or add. I mean multiply or divide. The unit that you are going to get is going to become a derived quantity. Okay, is that okay? Mark, are you okay?
Yeah, yes, it's okay.
Okay. So apart from this, you need also to know a scalar and a vector. So I've got scalar quantities and also vector quantities. You also need to know those. Okay. So I'm going to put here a scalar quantity, and then the other side I'm going to put a vector quantity. Now, if you talk of a scalar quantity is a quantity that has got only magnitude. If you hear the word magnitude, it just means size. Okay? Something that only has size but no direction. So that is what we call a scalar quantity. Now a vector quantity is a quantity that has both magnitude and direction, meaning that it has got both size and direction. So what does this mean? Okay, so if you are talking of something that has got both magnitude and direction, let's first start giving examples of scalars. Things which only have magnitude but have no direction. An example we talk about is currency. Not current, but currency. Okay? Currency. I also wrote current. So currency is just money. If you talk of money, you cannot say 20 kwacha east or 20 kwacha forward. It has no direction. Another thing you can talk about is mass. So mass has no direction. If you are 20 kg, you are 20 kg. Okay? Apart from mass, you also have distance. Distance is also a scalar. Apart from this, you also have speed. You need to know this because they come in the exam. And then for vector quantities, examples we can give, we have got weight. It is a vector because weight goes down, so you see there is a direction. You have got force. Okay, force, for example, if you are pushing something forward, it has got a direction, right? You have got velocity, you have got acceleration, you've got pressure. All these things are vectors. Is that okay?
Yes, it's okay.
All right. So another example I can give here is moment, or less, yeah, moment of a force. So moment is when if you have got a door, okay, you want to open this door, you are going to push it like this. Or maybe if you have got something like this, let's say you have put a plank on top of a pivot like that. So moment is just force multiplied by the distance. So that is also a vector. Okay. So vectors, you are going to say that they are going to be represented by arrows. Arrows are going to mean that is the direction. So that is how you are able to represent vector. So if you get to put an arrow, okay. So because of this, let's talk a bit about vectors. Okay, so since a vector is a quantity with both magnitude and direction, you are going to see arrows. If you see an arrow like this is representing a vector, and then you see maybe 20 newtons. Okay, 20, the newton is representing magnitude, that is size, how big it is, and then the arrow is representing direction. So something that has got magnitude and direction, then that is a vector. So for this one, you can see the magnitude is 20 newtons. The direction, you've seen it is going towards the east. Okay, now how do you get to add vectors? So you can add two different vectors, and how do you add them? Okay, so when you're adding vectors, we are going to look at some different things. So let's say you have got a box here. Okay, I've got a box here. You have got one vector going like this, let's say it's 20 newtons. You have got another vector which is going like this, let's say it's 5 newtons. They say find the sum of these vectors. So when you're adding vectors like this, the resultant, okay, the resultant vector, that is the total is going to be, because they are going in the same direction, you are just going to get the 20, you add to the 5, that is going to give you 25 newtons. That is going to be the total for this one. Is that okay?
Yes, it's okay.
Okay, so let's say you have got something like this. You have got a force going like this, let's say it's 20 newtons, and then you have got another one going like this, let's say it's 20 newton, let me say 25 newtons. You want to find the resultant. So the resultant in this case is going to be equal to, you are going to get, okay, this big number here, which is what? Which is 25 newtons, minus this small number which is 20 newtons. That will give you 5 newtons. Now see, because 25 is bigger than 20, it means that the resultant is going to be in this direction. Okay, it will be going in this direction. So I'm going to say it is 5 newtons to the, you can say to the west, because this is west. When you are going to the west, you can say west or to the left. Okay, 5 newtons to the left. So if it was like this, you have got, let's say, 15 newtons this direction, then you have got 10 newtons in this direction. So the resultant in this case, we're going to say 15, the big one, minus 10, which is a small one. That is going to give you 5 newtons. So in this case, because the big one is this side, so the resultant is going to be in this direction. So I'm going to say 5 newtons to the east or to the right. Okay, is this clear?
Yes, it's okay.
Okay. So vectors can also be at an angle, and then they ask you to add. Let's say you have got a vector here. You have got this box. You have got one force which is going like this, and then you have got another force which is going up. So I've seen that they are making 90 degrees. Okay, so this is let's say 2 newtons, and then this is 3 newtons. They ask you find the resultant. You are going to be seeing these questions in the exam. So find the resultant. What you are going to do for this one, you are going to get this end of this first vector. You are going to draw a line that is parallel to this vector. Okay,
Okay.
and then you are going to also get this end, draw a line that is parallel to this vector. So like that. So where these two meet, the resultant means it's going to be going like this. That will be the resultant. At times they're just going to they'll bring a diagram like this. Okay, they would bring a diagram like this. If you have got forces like this, where will be the resultant? And then there are going to be options. They put like this, they put like this, they put like this. You need to know where the resultant is. So you've seen where the arrow is going, that is where the resultant is going to go. So to find the resultant in this case, so if this is 2 newtons, it means even this is going to be 2 newtons. If this is 3 newtons, it means even this is going to be 3 newtons. Okay, so to find the resultant, we are going to, because this is just a right angle triangle, I taught you about the Pythagoras theorem, right? You get this and this. Okay, you square them and square root. So it will be 2 squared plus 3 squared. And then the answer you get, you are going to square root that. So the resultant is going to be a square. 2 squared is 4, 3 squared is 9, meaning that the resultant is going to be the square root of 13. And then you just put newtons. So this is going to be the answer. Is this okay?
I have a question.
Yes.
How does 2 2 turns from down, left, right, others come from the front.
So there so if you have got lines which are like this, if you draw lines like this, okay, you have got lines like this.
This,
If this is 4
I,
yes, if you have got this as 4 newtons, this has 5 newtons. If you draw a line like
okay,
this line is going to be the same as this line. Okay, so meaning that if this one is 4, even this one I've drawn is going to be 4. And then you draw another one like this. If this one was 5, meaning that even this is 5. Okay,
okay,
so the resultant is going to be here. Is that okay?
yes, it's okay.
So to find that resultant, just get 5, you square it, you also get 4, you square it, and then you square root. So that is how you're able to find these.